can change it into exponential form, right? So if I start with log, I'm going to jump it into exponential form. Same thing, if I start with exponential form, I can rewrite it as a log, and that can help me solve the problem. So I'm going to rewrite this in exponential form. I need there to be a base. So what is the base when you have a natural log? E. So I'm going to write the E down there in the base so that I can change it into an exponential. So my base of my exponential would be E. The power is going to be a huge power, e to the 40th. So I'm not going to type this into my calculator. And that's equal to 2x. What would be my last step to solve for x? Just divide by 2 on both sides. And I would leave this as your final answer, because if you type e to the 40th in, you're going to get your answer in scientific notation, e to the 40th. So if you notice, it says 1.17. If you look all the way over to the right, times 10 to the 17th power is a gigantic number. So if you just want to leave your answer as e to the 40th over 2, that makes sense. All right, number 8. If I remember correctly, I forget if you need a calculator for this one. What would be my first step to get log by itself? So this whole thing right here is the log function. Divide by 3 on both sides to start. So I've got log piece 2 of 9x equals 8. So I'm stuck in log form. So I'm going to change it into exponential form. So what's the base of my exponent? Base is going to be 2 raised to the 8th power. You might need a calculator for that. Equals 9x. So you're going to do 2 to the 8th, and then just divide your answer by 9 at the end to get x by itself. Who needs a calculator right there? Yes. You have one in the side pocket? You need one? Or you got one? You got one? Really? Oh, I don't have enough. Those are dinosaurs. Did you need one? This one still works. I have 22 in my other two spots. You have to 9 now. 2 raised to the 8th power equals 9x. Right? Because you're changing a log into exponential. So this is your base, this is your power, this is your answer. 2 to the 8th is 9x. So we're doing 2 to the 8th and dividing by 9. So like 28.44 repeating. So x equals 28.44. That's what I got. 2 to the 8th divided by 9. Anyone need help typing that in? Did you kind of get there? 2 raised to the 8th power, right? I hit enter. So I did 2 to the 8th, then I divided my answer by 9. Okay, I wanted to show you quickly the bonus one, because some people in here like doing bonuses, and it's not really beyond you. It's just combining our properties of logs with the one-to-one property. So there's a natural log here, and there's a natural log here, and there's a natural log on the other side. If you have two natural logs equal to each other, it's kind of like the one-to-one property for exponents. Whatever I have up here has to be equal to whatever I have up here, right? So the same thing is true for logs. If you have a natural log of something equal to another natural log of something, all you care about is making these two things equal to each other, and you can get rid of the natural log. So we are going to first combine the left side. This is a plus sign. What's the property for logs? If you're adding two logs together, what do you get to do to the inside stuff? Remember natural log of A plus natural log of B? I can combine that as A times B inside the log. Remember that property from a couple days ago? Addition is multiplying. So I'm actually going to multiply together the x minus 2 times the 2x minus 3. because those are quadratics, or it's going to form a quadratic, a binomial times a binomial. So I really have the natural log of all that stuff. Nope. So you have to do first, outer, inner, last. Remember, there's 4 terms. You could use the box method. You get 2x squared. If I just did my outer, I would have negative 3x's, and then if I did my inner, I would have negative 4x's. I have negative 7x's altogether. You guys need the box. Okay, hold on. I'm just multiplying 2 binomials. Do you guys forget how to do that for unit 1? Whoa. X minus 1, 2x minus 3. I'm multiplying them together. 2x squared minus 4x minus 3x plus 6. Right? Or I'm just doing in my head first, outer, inner, last. So 2x squared, my outer plus my inner, negative 7x. I also get in the box. So then plus 6. All right, so this is kind of a bonus because it's relying on you multiplying these 2 binomials together. And there's another property going on over here. So what property did we learn? When there's a number in front of the log, what are you allowed to do to it? You can bring it up inside the log and make this x squared right here. So it's the power property. You can slide the power down front as a coefficient, or you can slide it back up and make it a power. So all this stuff is equal to just x squared, because that's what's inside the log on the other side of the function. So that was the properties to get it set up. A natural log equal to another natural log. All I care about is the stuff inside them are equal. Now to solve this quadratic, it's really not that bad because your first step is subtract x squared to get 0 on the right-hand side. And that gives you an a value of just 1, because 2x squared minus 1x squared is just x squared. Minus 7x plus 6 equals 0. I'm going to give you a minute. See if you can do the diamond method to factor. Sorry, you ran out of room. Maybe go down here into this open space. See if you can factor this quadratic. I hope you remember the diamond method. What are the factors of 6 that add up to negative 7? Write your 2 binomials. 6 goes on the top. Okay. Yeah, that's me too. Did you like No, I just said that this is equal to the natural log of x squared. I don't care about this because the one-to-one property says if they're both natural logs, the only way they're equal is if the stuff inside them is equal. So yeah, I'm ignoring the fact that there's a natural log. Because it's the same natural log on both sides, I can just ignore the inside. It's not going to be a bonus on the quiz. It'd be a bonus on the unit test. But did I put one for Tuesday in here or no? No, I don't think I did. I think we just have the review when we come back, a team test, and the test. No. Next week you've got 2 days of practice problems. No. Then we've got 3 days when we come back. But I don't think there's another quiz. No, it's just I throw it on there as a bonus. It's not as hard as you think it is. It's using the properties, but this can be hard for you because we haven't done this since unit 1. Right? Solving this, yes. Okay, 1 second. Did you guys get the factors? What are the factors of 6 that add up to negative 7? X minus 6, x minus 1. Okay, you got that. So what are your 2 solutions? 1 and 6. If you got that far, I would be so happy and I would give you 1 point of extra credit. But one of them doesn't work. Or you shouldn't be grouping. So why did you choose negative 7? You should have chosen does that make sense? Okay. So one of these works when you plug it back in and one of them doesn't. I want you to look at this first factor up here. What would happen if I plugged in 1? So if I plug in 1, I get negative inside a log. What is the domain of a log graph?
Oh, yeah.
Can the domain ever be negative? So it's called an extraneous solution. 1 actually does not work when you plug it back in because it makes the log negative inside the log. This is definitely an advanced question because it relies on properties, quadratics, and an extraneous solution. But I think some of you could get it. So I wanted you to see the strategy. Combine the logs and solve the quadratic, because I think you need to know how to solve quadratics. But 1 does not work. So the only solution is 6. When you plug in 6, it will make it true. Okay? So the only solution, I'll write it on here. X minus 6, x minus 1. X is 6 or 1, and I'm going to cross out the 1. All right, I'd like you to take the time before lunch. Oops, yeah. You can work together. See if you can answer 1 through 6 on the next page. If you forgot to copy them down, I have them written up here so they're more legible. Round to 2 decimal places using your calculator. And see if you can go 6 for 6. I'm solving logs and exponents. So you have 10 boxes here. So this seems familiar. Okay. on this one, because we have exponential on both sides of the equation, you're gonna try to make this into a base that's the same. So you want to make it into a base that's three, right? It's 3 squared. And the 2 is gonna get distributed up here to this exponent, so you have 2x minus 2. So this side would be 3 to the 2x minus 2. This side is 3 to the 6x plus 1. So you can say your 6x plus 1 equal to your 2x minus 2 and solve for x. Did you guys figure this out on something? Line number 1 equals right, so you're always both sides of the equation the same base, right? So what she did was she said, is this 3 squared, and this is the x minus 1 power. This has to get distributed. So this is 3 to the 2x minus 2 power. That has to be equal to that. So you can ignore the 3 and just look at the exponent. I need to make 6x plus 1 equal to 2x minus 2. I'm going to subtract the 2x first, so however you can solve for x.
That's gotta be close.
Keep that, you're trying to get these. Only caring about these is what's in there.
Instead of doing a log with a t, you can type the natural log of whatever you choose. Then you'll be dividing the two.
And then the rest is
Okay, so the reason I showed them that is so that you grab the log graph. Just graph yeah, but you know what? So you're not going to tell them to make a table that you want to so what you want to do is at the end of the first.
bring it down back.
You guys have about 2 minutes left. Are we able to go over these 6 questions after lunch? Are you almost to the end? Need help?
For number 2, for actually bring that down like to the log.
Base 4 of 12 equals x. Yes, and then that you can type into your calculator. No, you don't want to guess and check. You want to rewrite it as a log. Like, so the log base is going to be 4. The 12 goes inside the log. And now you can type that in to get x exactly. You're changing it into log form. No, you're going to type log base 4. Log base 4. That's under
What
the
you're doing.
because 4 squared is 16. No, right? So
These can't be equal yet because the bases are not the same. But they belong to the same family. So how is we going to get 9x equal? How are we going to get 9 equal to 3? 9 equals 3. So you're doing like, so 3 equals in parentheses. Then x, and you put it in x. And then x minus 1. Because we only care about the 6x plus 1 and x minus 1, we need to get that exponent up here. We need to get that 2 in here as well. So we need to just distribute by just multiplying 2x, 2x, and then 2x, 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 negative 2. So then 9. All we care about now is just x plus 1 equals 2x minus 2. And then you're just doing the algebra, like subtract 1 from both sides. So now you just have 6x equals 2x minus 3.
Well, you should be doing. Okay, so over here.
Subtract 2. 4 equals -3. So then divide by 3. Yeah, right?
You want to convert this into log form. I'm going to give you 4. 12 is inside.
No, the 6 is already here.
Okay, but you want to figure out exactly using the
It's
log.
been there the whole time.
So on this one, the base would be E.
That was the principle. It was always there. The 6 was always there.
Times X.
Yes.
Natural log.
Yeah, the 6 was always there.
Of number
So that's why, like,
divide by 2.
the 6 is the answer.
So what you don't know how to do is convert it into the other form. All right, this is that great. I think that I should go. This is 12, isn't it? Yeah, so why don't you guys go to lunch? Are you good before you go for lunch? Okay. Yeah, follow the crowd. Make sure she gets to where. Oh, good. Okay. Oh, did that crash? Oh. I think it was the thing on the other side. No, that's fine. That's just the long. God damn it. Okay. All right. There's still going to be a Christmas. I think we kind of did together. This one was 3 squared, right? So this becomes 2x minus 2 in the exponent and 6x plus 1 in the exponent. So you subtract the 2x to the other side, you get 4x equals -3. So x was -3/4. I looked at most of your papers and I think you got number 1 correct. Number 2, you just type into your calculator as the log base 4 of 12. So the log base 4 of 12 comes out to what? 1.79 should have been the answer to number 2. Did you get that? Then number 3, you type it into your calculator. The log base E of 13 equals 2x. Well, this is just the natural log button. Natural log of 13. And then to divide your final answer by 2, you get 1.28. I think most of us got that one done. I think the 2 and 3 are the hardest, converting into log form. My brain sees the logs to exponents easier, I think. So at number 4, your first step is to divide both sides of the equation by 2. You have log base 2 of x equals 4. This you should be able to evaluate mental math. 2 to the 4th power is equal to what? For number 4. Right, 2 to the 4th is 16. So 16 is what should be inside that log on number 4. So number 4 would be like a no calculator question on the test. All right, number 5. I need to get this natural log by itself. So I would add 4 and then divide by 3. Natural log of x would be 4/3. Add 2. Add 2 to get 4 and then divide by 3. Now I have the natural log is equal to 4/3. So what's my base? My base is E, and I need to change it into exponential form using my little circle here. E raised to the 4/3 power is equal to x. So I think some of you need to practice going between log and exponential form if that's hard for you. Would I get what? What is 2 plus 2? 4. And then what's 4 divided by 3? So I added 2 to the other side, and then I said the step in my head, divide by 3, and I got 4/3. I need to write that step down, divide by 3 on both sides. So what did you get for that? What is e to the 4/3 power? You have to know how to go between log and exponential form. So if 2 cubed is equal to 8, that's log form, the log base 2 of 8 equals 3. Because they made up a function called a log to be the inverse of exponential. Why did they make up this function? They basically be the inverse of this function. So they're functions that allow you to go forward or backward, I think, in an equation. Okay. To solve things. So we haven't gotten to the applications yet, which I wanted to get to today, but what is e to the 4/3? 3.79. I'm not going to do a discussion currently, but we could talk about it later. The last one, I need to get this log by itself. So what would be my first step? Subtract 3 from both sides. Negative log x equals 2. What's my next step to get log by itself? Divide by -1 really is what you're doing. So you get log by itself. What's 2 divided by -1? -2. And then this would be a no calculator question because you should be able to do this one in your head. What's the base of a common log if it's not written there? 10. And you should know what 10 to the -2nd power. This is the power. This is the solution. What does a negative exponent do? Fraction, and you're squaring the 10. So 1 over 100. So we need our negative exponent rules to solve without a calculator. So if you haven't had a chance to do 4, 3, 4, 4, 4, 3, and 4, 4 will practice this a bunch, going back and forth to solve equations. And so we'll be finishing that log 1 through 30 worksheet for practice on Monday. So I just wanted to start 409, even though I think we'll have to work on 409 once we get back. 410 is investment. So can you just go to page 410 for now, the application practice? Can you circle number 7 and number 8 that you're not going to be doing those without me? So just write skip on 7 and skip on 8 on 410. Because you're working on it on Monday and Monday, Tuesday. The front. No, so we're going to 410. I'm just talking ahead to what you're going to need to do on Monday, Tuesday. See how 410 says application practice? The whole first page is just interest. You've done interest. You can guess and check with interest. You guys can do interest without me. You don't need a video for that. And then for 7 and 8, I said just circle them and write skip for Monday, Tuesday. Those are the ones I'd have to leave you a video for, but we're not going to have a lot of time right now to get through 409 and understand it. So the 7 and 8, I'm going to have you skip for Monday. But number 9, this is just like plugging in information into an equation. So you could try number 9 when you're with Miss Allen. Okay? That's just planning ahead for when it says up here, 410. I'm not going to write with video help because you're just going to do the ones that don't need the video help. I'm going to write skip number 7 and 8. Okay. I do want to show you 409 just to show you where we're going when we get back. Probably the day we get back, Monday, will have to be like application work. So then we would be taking the test Thursday instead. So you'd have Tuesday as a review day, Wednesday is a team test, Thursday is a test. So if you're planning ahead for the week after Thanksgiving, that might help. If we do an application day. So here's 409 though. I want to show you where we're going because Kaden asked a really good question. Why do we need logs? When are we going to use them? And the whole reason we use them is to actually solve application problems. Oh, we still need to do the hot chocolate problem too. So that we'll do when we get back. That'll be a good application practice day after Thanksgiving. So this says, in our last adventure, we talked about compound interest. Remember? PE to the RT C for compound interest, continuous compound interest. Now we're just going to use the equation a sub 0 e to the kt. So a lot of the equation is the same as compound interest. K changes. So whether I put my water in a mug or a glass beaker, it's going to change the cooling rate. K might change also for like a bacteria. If it's in a really great agar dish that it likes, it's going to be very prolific and the population is going to skyrocket, right? But if you're leaving it in a really cold refrigerator, the K value probably will be very low. The bacteria will barely grow on the dish, right? Because of the surrounding medium. Or you might be decaying. K is negative, you might have decreasing function. Classic examples are compound interest or population growth or radioactive decay. So if you have you heard about like radioactivity, right? So we're worried about like uranium, whatever, in nuclear fallout because it takes a really long time to decay. So it's dangerous to people with the radioactive isotopes for a long time. So even places like Chernobyl, where they had a nuclear spill, there is still radioactivity there. That was in the 80s. So this is like 40 something years later, right? Because the K value is really low for radioactive elements. So the simplest application would be in science if I know how fast my insect population is growing. Do you need something? You couldn't hold it for 10 minutes to just let me get start from pushing everything one day to our test. All right.